Welcome everyone, good afternoon. Welcome to one of a series of seminars organized by INU Institute for Climate, Energy and Disaster Solutions. As all of you probably know, the Institute is trying to bring together all of INU research in energy, in the field of energy, climate and disaster solutions. And our group here, Genevieve Newley and myself, we are responsible for energy part of it. We love energy and we work with energy. I work in energy field all my life. My name is Igor Skrябin. I am Research and Business Development Manager on Energy of the Institute, and I'm also in parallel convener of Master of Energy Change program in Physics at AIM. So today we have one of our great events. Yeah, the room is not full. How many people do we have online? We don't know. 5. Okay. So then we have very good and family environment. Will be very informal today. So today's seminar will be presented by Dr. Rabin Basnet, which he has a very interesting biography. He is a mechanical engineer by undergraduate training, but then moved to photovoltaic area because destiny brought him to Fraunhofer, right, which is the center of photovoltaic worldwide, just at the same level as ANU photovoltaic groups. Then he completed ANU PhD at ANU in School of Photovoltaics, because it's engineering, but actually photovoltaic groups. And as probably all of you know, our photovoltaic at ANU is world leading, is one of 2 major groups in Australia. One is at ANU and second is at UNSW, and probably one of, I think a dozen of leading groups worldwide. And if you come, for example, to China and look to major companies dealing with photovoltaics and manufacturing photovoltaics, most likely you'll find the CTO of this company graduated either from ANU or UNSW. So today's topic is very interesting. It's not direct photovoltaic, but actually end-of-life photovoltaics. And what to do with silicon solar cells when their life expired, when they close to end of life management, right? It's a very interesting topic. You know, I recently attended Australia-China Energy Transition Seminar, and this issue was broadly discussed there. There were several propositions, including ridiculous proposition of kind that countries supplying photovoltaic should take it back like a nuclear waste, right? And manage it back. So I don't know. Another proposition was for Australia to take part in photovoltaic manufacturing chain by dealing with recycling, right? Because we have plenty of land and good recycling skills. But anyway, so we will hear, of course, more details today, more technical details, and what also I want to say, and pleased to say that this project was funded by the ACT government, because as you know, ACT government has a very strong renewable and sustainable energy agenda, and as part of funding, they raise through auctions, renewable energy auctions. They're capable to fund research projects. We have there were a couple of beneficiaries of this funding, right? I know them. So this funding is continuing. Everyone is welcome to apply again. It's now next round will be open in a couple of weeks. And I encourage everyone to apply because I'm a member of the board, advisory board that makes this decision. So anyway, Rabin, you. Thank you very much.
Okay. Okay, thank you, Igor, for kind introduction. Good afternoon, everyone. I'm Rabin Basnet from School of Engineering, and today I'm going to talk about the PV, but it's end-of-life management. And even in the end of life, I'll try to focus more on the reuse aspect than the other strategies that we commonly see. And as Igor mentioned, so this project was primarily funded by ACT government along with PV Lab, and also with the Circular PV Alliance. So we 3, ANU, PV Lab, and Circular PV Alliance worked on this project to understand better how to reuse the PV that are recently decommissioned. So I'd like to make this seminar as informal as possible, so there is no very strong structure. It's like that's why at the end of this seminar, I hope you will understand, if you haven't yet, what the end of life management of PV is, and what this PV reuse in particular means, and what's happening today on this reuse aspect. Reuse aspect of the PV. Okay. Temperature warning. Okay. So we know that.
Sustainability.
Yeah. So we are in an existential crisis, right? So because of this climate change and global warming, and we aim to reduce our global temperature rise within 1.5 or less than 1.5 degree by 2050. And for that, renewable energy is one of the most straightforward way of electricity source. And within the renewable energy, PV is one of the biggest contributor. So if we deploy the PV, then we have a greater chance of achieving this reducing carbon emission target. And we know that in recent years, the PV deployment has increasing significantly, in fact, in an exponential rate. And it is because of the continuous reduction in the price, as well as the several government initiatives as well. Yeah, so and then in terms of, if you look at in a country-wise, the list here is a top 10 for the cumulative PV installation, as well as the annual installation rate. If you look at the cumulative installation, the total PV installation capacity, China has around 660 gigawatt, which is way higher than any other countries involved. And if you look at Australia, we are still in the top 10 in the total PV installed. We install around 36 gigawatt as of today. And looking at the population that we have in Australia, it is still the highest proportion. If you look at in a per capita, Australia is in the top 3 of the PV installer in the world, which is a good thing, and we should be proud of that one. But that's not enough. And in terms of the Australian role, as Igor mentioned, it's not only the installation that we are doing great. I think our role is about in the R&D. I think UNSW and ANU should be proud, and we as a whole should be proud that we are one of the biggest biggest contributor in the R&D development. In fact, the current PV technology that you see in the market was developed at UNSW. So that's one way to be proud of for Australia. But okay, so the reason why we have this large installation at the moment is because of this, can be understood by this learning curve. You can see in the bottom right there. So what that curve means is that this is the log curve with the cumulative PV installation and the average price of the module. You can see back into the 1980s, we had a module price around $100 per watt, and now it has decreased to around 0.2 cents. So several order of magnitude has been reduced from 1980s to now, which is significant achievement that we see. And it is mostly because there is improvement in technology. The efficiency has been increasing quite significantly. You can see on the top right figure here, you can see in the early 2000s, the module efficiency, the typical module efficiency was around 10 to 12%, but now it has reached up to 22, which is big in this technological scale. And also there is a huge other innovation throughout the value chain of PV. So now the PV is a multi-billion-dollar company on its own. So it's because it's a company on its own, like a business on its own. So the innovation is everywhere in all the supply chain. There is a big innovation, and that has contributed in the improvement in the technology itself. As a result, so we see exponential growth in the deployment, and which is what we want. And we want even further decrease in the price. And that is where we work. I primarily work with the technology development, thinking that we can reduce further cost of this system. Now, so I think the next thing that I want to say here might be a controversial, so please be aware. So what I'm thinking that could happen in the future is, since the price is gone so down, like so cheap now, can we see a fast PV, like similar to the fast fashion is happening there? So instead of having the PV for several years, which I will mention later, then I think since the price has been gone down and the efficiency is improving, then I think the people will tend to deinstall the PV module in a short span of time, like in the next 5 or 10 years. Then I think there will be more turnaround of this PV module, and that what it results is then the volume of the decommissioned PV will increase. Okay, so this is the background of what I'm trying to mention here. It's not that only the end of life that coming after the 20-25 years of life, but there are chances that significant volume of the PV will be decommissioned way before their service life. Okay, so talking about the service life or this technical life, for silicon PV at least, so we generally expect around 25 plus years of service life. That is the general acceptance, that is what we believe, and the system will survive. But in reality, significant volumes of the PV are decommissioned way before 25 years. I think depending on which data you look at, there are many studies on this one. I think 10 plus years, like 10 to 15 years is the average life of the PV. So what that means is that if you decommission after 10 years, then hypothetically there is another 15 years of usable life on that module, and what we will do on that one, right? That's the main question here. And then the reason for this prematurely decommissioning can be different. There are many factors contributing to that one. Some of them I listed here are repowering, damage, and technical failures, continuous degradation, which is again related to the technology itself, and then the economic motivation. And one particular example that I want to show you here is this news here. It's the recent news in early 2004. This year, 2024. So I'm saying that this is not happening every day, or this is not happening that regularly, but this is just give you the example of how this decommissioning is happening. So this example is shown in also Western Australia. There was a power plant, solar power plant, with a 10 megawatt of capacity. That means around 34,000 of PV modules were installed. And that power plant was primarily installed to power the mining activity there. So after the 7 years, that mining activity has been finished, completed. And then there is no use of this power plant. Now the company is trying to deinstall all this 10 megawatt of power plant. That means we have 34,000 of modules. And then we don't know what to do with that one, right? So hopefully it will be reused, and then company Neon, they promise that they will try to find a new life on these modules, and they will reuse them in some way, but not sure what's happening at the moment. But still, you can see that 34,000 of modules in one location after only seven years. In a worst case, they will join the waste stream, right? And we know that these modules, more than 90% of these modules can still be reused for another 10 to 15 years as it is. So, what this means is that there is a research gap. So in most of the slides, I'll try to find the research gap in this area so that some of you might be interested to look at this in further, and then hopefully we can collaborate as well in future. Okay. So what I'm trying to say, the useful life is depending on where you decommission and how you decommission, and many other factors. The useful remaining life of the module definition is very important, because that's a very important metrics for the reuse of the PV. All right, so let's look at what's happening at the moment. So the current practice, we label it as a linear economy, and it is true for many other products, not specifically for the PV. So what's happening is, so basically it's a take, make, and dispose kind of economy or practice that we use for the PV. So we install PV, Like we buy PV, install PV, and after certain years we just dispose it. And we know that the disposal in the landfilling, it's not a sustainable way of practice. In several countries, they already started banning this landfilling of the PV modules. Here in Australia, already Victoria, and I think South Australia also have looked at have banned this landfilling. So that means you cannot landfill your decommissioned modules on those estates. And hopefully in next 2 years, it will be Australia will ban this one, and then we need to think what to do. So one thing that I want to highlight here is EU's initiation. So EU is quite active on this area, on the sustainability, and EU already had this directive in 2012 on the banning, or basically looking at the recycling or the end-of-life management of PV. So one aspect they have highlighted here is that when you have a decommissioned PV module, you should recycle 80% of that particular module. That means by weight, before you are eligible for the landfilling. But the bad thing about this by weight concept is that, you know, when you look at the PV modules, most of your weight comes from the aluminum or the metal frame, right? Basically, if you can extract the metal frame and some of the glass, then you basically meet this criteria, right? So it is something, but not enough to achieve the proper end-of-life management of an PV module. That's why we need to look further than this linear economy. And if we don't do, then what will happen, right? So there will be lots of negative headlines. And we know that PV is one of the like a thing that during the initial days and even today, the PV was developed based on the sustainability aspect, based on its renewable energy, green energy, and all this good thing about it does to our future, right? So if you have this kind of negative headlines, to some way, it will help to mislead the general public, and hopefully in the long run, it might affect the whole image of the PV system. That's why we need to look at the proper way of managing the end of life of PV. Okay, so one thing that I want to highlight here is, okay, so far we talk about, okay, the PV installation will be increased. There will be increased volume of the PV waste coming into the field. So how that looks like when you look at the bigger picture, if you look at the whole waste stream, right? So this is the work done by Andrel in the US, and they have compared the different waste stream in the whole world, right? And they projected until 2050. So if you look at the waste coming from municipal waste, they are the big chunks of the whole waste ecosystem. And then there is a coal ash, plastic waste. And if you look at the PV itself, it's very small, right? If you look at those big, like elephants, it's a very small quantity on its own. And in fact, in the very worst case scenario, PV will be less than 10% of the e-waste, not the whole waste, just the E, like electronic waste. So what it means is that in a bigger picture, we don't have to worry, but I think that's not enough. And that since PV being a renewable, sustainable source of energy, I think we should do more than what plastic is being done, right? So yes, people are trying to do the plastic recycling, but it's very complicated and very hard to do. There is an effort there, but still we can do better than that, and we should do better than the other source of waste. And in Australia, if you look at Australia, this is the waste projection done in 2019 to 2030. You can see here, you can see in 2019, and the waste from PV and battery was less than 5% in Australia, but it is projected less than 5 tons of e-waste. But if you look at the in 2030, it will increase by 1700%, right? So in 2030, the waste from the PV will be significant. And the reason behind is that Australia, I think in Australia, it was early 2000 or mid 2000 where the PV installation was happening in a massive scale, especially in a rooftop system. That's where, and then assuming that they survive for 25 years or 20 years. So now those first generation of installation are coming to the end of their life. That's why they will join the waste stream. And that's why we see huge surge in the quantity of the PV waste, potential PV waste coming into the system. Now, so the other thing that I want to highlight here is the resources dilemma. So we know that we need more and more PV, and then I think we need more than in the scale of terawatt scale annual installation. That means billions of panels needs to be made per year. So if we, and that is what we need to do. I think we shouldn't reduce our installation and fabrication and manufacturing of these panels. That should be done. But if we do that, then there is a side effect of the resource utilization, right? We have a finite source of resources, particularly silver, copper, and other minerals like indium and bismuth. So in 2020, there was a study, depending on which study you believe, but this particular study said that almost 12% of the total silver supply was consumed by only PV industry in 2020. And from 2020 to 2024, we already have a huge jump in our production capacity and deployment capacity. So if you assume that in next 10 or 20 years, with the increase in manufacturing and deployment, these resources will be huge, right? The resource demand will be huge. And the people are, so at least the researchers are working hard on to reduce this consumption, especially the silver consumption. It will reduce the silver consumption per cell in future, but still, I think with the scale of volume of the PV manufacture, there will be a limitation on the supply of this mineral. That's why we need to look at on this end of life PV. Can we source, either we need to extend the life so that we have less demand of these minerals, or we can use urban mining using the recycling. Basically, that's what the recycling people are trying to do. So they have the end of life like decommission module, and they want to extract the silver out of those old panels and then use that silver again to manufacture the new one. And that's why we call it the circular economy. Basically, we feed back the resources from the old panels back in to make the new ones. And this is very simple pyramid, and that inverted pyramid that can be used for the circular economy. And it's based on 10R strategy. Basically, this economy is applied to any commercial product. So it's not necessarily to the PV only, but this can be adapted in a PV as well. So in this 10R strategy, there are different sectors. So the first three ones, the refuse, reduce, and redesigns, are mostly during the designing phase. Basically, that needs to be considered when we manufacture the PV. Basically, the PV manufacturer should look at this aspect. And the second one, the reuse, repair, and refurbishment, is during the consumption phase. That is like people like us, when we use our system, either we need to reuse or extend the lifetime of that module so that we don't have to buy new ones. Hopefully, yeah. And then the other one, the recycling, is the least preferred method for this from the circular economy aspect. But if you look at the current end-of-life management in PV, you will see most of the time people are talking on the recycling rather than the reusing, right? So the problem of I'm not against the recycling. The recycling needs to happen. And it is absolutely necessary that we need to have a proper and effective 100% recycling strategy. But I think before that, we need to consider the reuse aspect as well, because with some of the modules, they have the embedded energy, right? If you just recycle right away, then their useful life of another 10 to 15 years will be wasted. And also, I think one thing that we need to be sure, or I will talk later as well, is reuse PV modules, they have a certain area, like they have only usable for certain area. It's not a universal application. I don't think that I can convince anyone saying, okay, you need to have a reuse module and then go to make a power plant, utility scale power plant based on the reuse PV. I don't think that I can convince any financier or any developer on this one, because the modern PV modules are highly efficient, high performing, and they are cheaper enough. That's why we need to find a new ways or new market for these kind of modules, which I will talk later. Okay, so until now, I talk a lot, I think, but I didn't mention about the reuse, what actually the reuse is, okay? So the reuse basically, in a very simple term, is a reinstallation of the decommissioned PV modules in another locations after appropriate quality control, okay? So basically, you decommission from one location and then you install into the another location for the generation of the power, but with the appropriate quality control. So in this case, so I'm talking mostly on the reuse of the modules, not on the individual component. So basically, when you look at the recycling, sometimes the metal frames can be reused as well, and they claim it as a reuse as well. But in the seminar, this seminar is mostly about the reuse of the module, the whole module is alone, not the individual components. Okay. So when you look at the reuse, so it has its own ecosystem. Hopefully, there is a business opportunities on this one here. So the reuse journey of the reuse primarily starts from the decommissioning. So when you think of decommissioning your plant or your rooftop system, then you start thinking what to do, because the way you decommission for the recycling and reusing might be different. And then also the storage, testing, and then the sale or integration. So these are the steps that we need to consider when you're thinking of reusing. And the other thing that I want to highlight here is when you talk about the PV reuse, we need to talk with the different stakeholders on this concept. And two main stakeholders that I generally find have a different opinion sometimes are the recyclers and a PV manufacturer. So recyclers currently, they don't have enough economies of scale to make their system, to make their business profitable, because there are not enough modules coming to them every day to run their system in a profitable way. That's why they sometimes think as a delayed customer. So if you extend the life of your decommissioned module, then they might think it as a delayed customer, basically. But there are some improvement as well. So some recyclers, they have considered this reuse as an opportunity, business opportunity, and they have worked basically in the two aspects, both reuse and recycling, which is a good thing to happen, and also the PV manufacturer. And sometimes they might feel as a competitor for their market share, which I don't think it's happening, because of the whole market is so big for the new modules that the reuse market will be really small for them to be competitive. But also, and also the manufacturer think from the warranties of their own product, right? They don't want to associate with the product of their own product that might have something uncertain in the future. So they don't know what will happen to the reuse application. So we will look at the danger or the barriers of those reuse application as well. Now let's look at the data. So when you look at the data, being academic, I generally look at the volume of the articles published on certain aspect, patents, industry reports, and basically counting the number of the recyclers in the world. And all these factors will help me to understand how is the state of the reuse, PV reuse, in comparison to the recycling. So if you look at the publication volume, there are hundreds of publications. In the recent years, we see more than like 200 of publication in a year, which is not a big publication if you compare with the other areas, but especially on this end of life management sector, this is a big volume. You can see here the publication has been increasing lately. And also in the patent case, the case has been increasing. More and more people are filing the patent because they find a new way of recycling, new methods, new technology. That's why more and more interest is in the patent case. But when you look at the reuse, the scientific articles that are particularly focusing on the reuse, there are less than 20, not enough, even less. I think almost not even 5% of the total volume of the end-of-life management related articles. So this tells us that the reuse is kind of forgotten case in this case here. So that's where this forgotten word come in this seminar, okay? And we have done in the recycling area, I think Australian researchers have done quite nice job. So far, we already have more than 50 articles that where the Australian researchers were associated. But another thing that we have done really good is the industry report. It's not the peer review, not the scientific reports or scientific paper, but in the industry report, I have listed here the 6 of them. The Smart Energy Council's report is coming soon. I don't know if it is already arrived, but there's a big study going on this one, and they were targeting to publish sometime in this August. But there were some other studies as well, and one of them is in here, so which along with the PV Lab and Circular PV Alliance, we published this one recently. And all these reports are mostly talking about the reuse aspect of the PV, what can be done, what is the status, current status, and all those things. So there is an interest in the Australian community, but we need to do more on this one. I think so far this is mostly the literature review kind of or desktop research kind of thing. So we need to do more in a field to basically work on the better use of these reuse modules. And finally, the data that I want to show here is the recycler. PV, these are the global PV recyclers. And these numbers can be changing because the lifetime of the PV recycler has been very tricky. Many of them don't survive for long because of many problems, but still this is done in 2022, 2023, and recently 2024. So there are many recyclers, mostly in the US, Japan, Germany, and China. And in Australia, there are 11 or 12 companies. They are working with the PV recycling, not particularly on the level of recycling might be different. So if you can just extract the aluminum frame, sometimes they claim as a PV recycler, which is not completely true in a sense that recycling is very incomplete in that sense. So we need to achieve the recycling more than 95% to properly recycle these modules. And on this, okay, so this is slightly skewed. All right, so on that, so among these Australian recycler, I like to focus here the Blue Tribe and PV Lab Australia. These are the 2 companies, and they are trying to focus on the reuse aspect as well. So I'll talk slightly later about their business case. But just I want to highlight is that these 2 companies are doing brilliant job, are basically starting a conversation around the PV reuse. I think I must acknowledge their contribution on this area. Now, so finally, let's look at the PV reuse from the different aspects of when we talk about the PV reuse, we mostly talk about from the profitability, from the economic aspect, right? So every time you talk to some people, then you will talk, okay, how can it make profit? Where is the profitability coming on? That's where the people are trying to focus. But what I'm trying to focus here is that's not enough, and we need to have more holistic approach. From the legal aspect, we need to have improvement or the support from the legal aspect, from environmental, from technical aspect, and everything. So that must come together so that this PV reuse can be successful. Now let's look at the legal aspect. At least in Australia, in fact, all around the world, there are very few regulatory framework that consider the reuse of PV. Basically, there is no support from the legal aspect. In Australia, I think we cannot have the reuse PV in our grid connected system. Basically, I think if you want to install a PV in your rooftop, that should be approved by Clean Energy Council, and Clean Energy Council update their list of the module every year, I think, and then they basically remove the modules older than 3 years. So if you have a modules that were manufactured 5 years or 10 years before, there is no way that it can be approved by CEC. And the reason and the problem for that is then you cannot claim this small scale technology certificate scheme, right? So you cannot have the advantage of this scheme. And hopefully this certificate will expire. I think it's expiring in 2030. And from after 2030, then there will be a new round, hopefully accommodating the PV reuse, but PV reusing, but after appropriate quality control. That's the necessary thing. So in terms of the drivers, yeah, we need to do lots of things on this legal aspect. It's very, this is very surface level highlight here. So basically we need to have the warranties, landfill bans, and then the main problem here is the insurance and liabilities. There is the insurance compliance doesn't work with the PV reuse. It's very complicated, and that is necessary for the consumer, right? So we need to do more on this legal aspects. So for a researcher, I think we need to discuss or find what can be done, like from the regulatory framework to help for these PV reuse, and also can there be any sort of incentive mechanisms on this one? And those are the things that we need to look at. Now let's look at the literature from the technological aspect. So there are a few studies, like I said before, there are only less than 20 PV review, like peer-reviewed articles focusing on the reuse of PV, and few of them I have highlighted here. So you can see there are many, like these 5-6 studies. They are from different parts of the world, and they use a different sample size, and then the panels of different age. And they use the different methods of testing, like a visual inspection, thermal imaging, and current voltage, and all these things. And then they claim a different amount of reusability. Basically, like there are numbers from 60 to 96% of the reusability means, right? So the problem that we find here is there is not a well-defined reusability criteria. What is the reusability criteria? How can you say, or what can be seen as a reusable PV? Can it be like just the power? If your decommissioned module has 80% of your initial rated power, can it be classified as a reuse? Can it be classified for the reuse? I think this is what we need to look at. I think there is a huge gap on this. What can be called a reusable PV? Okay, so I think I mentioned before these two companies. So the PV Lab and the Blue Tribe, they are the one very active in this space. So the PV Lab's vision is to have the mobile like one testing system that can be fast enough and cheap enough, so that we can sort out the panels either for the reuse or recycling, right? That's what we aim for, and that is what everyone is aiming for, and that is what Blue Tribe is doing as well here. So basically, they have this mobile system, and they take to the place where the panels are decommissioned, and they do some electrical performance test. And if they have certain, if they meet the certain criteria, then they will classify either for the reuse or the recycling. But interesting thing is that I think we believe, at least PV Lab, and I agree with them, believe that that's not enough for the reusability, because one of the main focus should be on the safety, because these are the electric equipment, right? We don't want any fire hazard or the safety like electrocution from this PV reuse. So if we have any incidents on this one, I think that will have a big recuperation for the whole PV use industry, right? So safety should be prioritized. And then that safety testing is, again, there's a not a very good way of doing, at least this quick and then cheap way. There is, at the moment, we don't have that system. That is where both PV Lab and Blue Tribe and also us are working on the product development that can be used for the safety test in a fast and then a cheaper ways. And also that the missing in this context is the data. In most cases, we don't know the history of the PV that are decommissioned. We have some manufacturers' data sheet, but in that data sheet as well, so many information are not included. And so at least for the reuse case, we need to have as many data as possible regarding that module, and then that will help us to calculate the reusable life and also forecast their future. Okay, so this is one. So far, I did most of the literature review kind of thing, and this is particularly the experimental work. We are working with the PV lab, and again from the project funded by government, the ICEDS government. So in this world, so what we're trying to do is PV modules. One of the main failure mode of the PV module is the rear side polymer failure. When you have a cracks on the rear side, then the moisture will ingress in it, and then that will do the corrosion of the metals as well as the encapsulant, and that affects both the safety as well as the electrical performances. So what we're trying in this work is that we use the old modules with the backseat problem, like backseat cracks, and then we use the silicone sealant from Dow Chemical, and basically we spray. It's like a coating system, very simple process. And we did, I think last week we did a test, and then our initial test result shows that it can help to prevent this failure. So basically, after the coating, the modules are working fine, but still we need to confirm with the long-term reliability using other standard testing protocols, and which we're doing. And hopefully, in a few months' time, we'll come up with the final results, and then let everyone know what happened to our project. So basically, this is one particular example of reuse case. Even though in the recent new modules are like glass modules, so that means there are no polymers like this one in here. So this kind of repair work will not be applied on those modules. So the future is slightly different, but for the current stage, there are lots of these glass backseat modules, and which has failed because of this problem in the backseat, and that can be repaired by this coating system, a coating process. Okay, so the other thing that I want to highlight here is the technology itself. So so for the improved technology, we need to have a cheap and the fast, and for that we need to be able to measure in the mass scale. Okay, and then for that we need to use this new system, like new technologies like the drone-based or machine learning, to have the proper way of sorting the reuse of PV. Okay, I think I need to a little bit hurry now. Okay, so from the economic, I think this is the most important aspect as well, because everyone will believe everyone try to understand from this aspect. So think that where is the market? I think, is there a market on the PV reuse? That's what I'm trying to say here. Market do exist. Although it's highly regulated, it still exists. Even in Australia, you can find several Facebook posts or LinkedIn posts, or in Gumtree, you can find people buying and selling old modules. It's in a very small scale, but yes, there is. But in US and in Europe, there are platforms like a PV exchange where the people actually buy the modules similar to the eBay kind of concept. So basically, they buy and sell there. And in the study from 2020 projected there was a 1 gigawatt of PV module, reused PV module market. That is quite a big, right? But I think the most, one of the biggest market of this reuse is this export of the decommissioned modules to the low-income countries. And this is still happening. So basically what they do is someone basically collects the modules from Australia. They don't do any test, and they just chuck it in the container and take them to either Africa or some other countries and sell there. And then we don't know what's happening there. So it's very unregulated. But in the next few years, I think Australia will, aiming to ban the export of e-waste. And then I think this will be regulated by that time. But at the moment, it's still there are a huge amount of modules going abroad. And then, hopefully we're not just relocating our waste. That's the main concept. In terms of the profitability, the cost, I think we need to consider the cost of this reuse. Basically, there is a cost of decommissioning, collection, because the PV system are highly decentralized. So there is a cost of collection, transportation, testing. So all these contribute to a certain cost. And then if we can compete with the new modules, I think the profitability will be very low. So we need to find a way that can help to improve the profitability, and some of the factors that can be done is by the financial incentives from the government, improved warranties, and also the landfill ban. So if there is a cost for landfilling your module, then people ultimately will look at the other aspect, right? Other avenues to reduce that cost. And there are a few cases as well. So from our studies, we found there are six areas of business that people are focusing for this reuse application. They are the collection, wholesale market, retail market, testing, refurbishment, and integration. So basically, someone will collect and then they sell it to the other one as a wholesaler, and then a wholesaler will do, they sort it out based on the visual inspection and things like that, and they sell a small quantity to the retailer and things like that. So you can see there is a business areas and people are making money out of this business area. So I have listed some example in here. So at the moment, if you look at the Blue Tribe and PB Lab, so the PB Lab is mostly working on the testing of this system, testing of these modules, and also the refurbishment. And Blue Tribe is looking at the testing and wholesaling of these PB modules. So there is a market, there is a business case on the PB reuse, but we need to deal with this question here. I think the public awareness, and then basically gaining the trust of the consumer is a big aspect on this case. All right, so the market identification is another issue that we need to talk about. So so where is the market for the PB reuse? Because we look at the PB module the new PB modules are getting cheaper and they have a supposedly longer life. So can this reuse PB with slightly low performance, and then also for the shorter lifespan, can compete with those ones? So there needs to be a market identification, and this is again a research gap that I think is very important to identify. Just one particular example that I want to show here is this is the case in US. They call the Equitable Solar Solutions. So what they do is they basically reuse the PV, and not only the modules, whole system, and then they use those system for the disadvantaged communities, basically to supply power to the disadvantaged population of the country. So, and I think even in Australia, we have this energy poverty, right? That significant number of the households are under the energy poverty line. That means they don't have enough energy, and with the present rise in living cost, I think that this makes sense. So we need to find, and at the moment I don't have the answer what exactly can be done, but I think this needs to be researched, or this needs to be worked out. Okay, so finally, there is one pilot project happening in Queensland along with the Smart Energy Council. So what they are doing is they are trying to, I think they are claiming as the world's largest test of decommissioned modules. So basically they are aiming to test more than 5,000 modules. And based on those tests, they want to develop I think lots of data like the data out of it, and that can be used for the reuse application as well. So basically the pilot line involves the collection of the decommissioned module. In fact, it is live now, I think from yesterday. So basically you can take your modules and then basically drop at this collection point. Unfortunately, this is only in Queensland. We cannot do from here, but yes, the Queensland people, they can drop now their modules there, and then the Smart Energy Council will collect them and transport to the central location, and that's where they do the testing. And based on the testing, they will either do the recycling or reusing. And then I think we'll have a very robust data set or evidence on from this project. So I'm really excited to hear the outcome of this one. And there was another pilot line in Europe as well, back in 2020, called Salt to Soul. There were 15 partners from 8 different countries, and they come up with quite a nice guidelines on how to reuse. So basically, one of the guidelines from this work has been used extensively on these PV reuse market. So basically, they have done quite nice work on that. So with this one, hopefully, yeah. So I'm coming. So I'm concluding my seminar here. So this is my expectation. Hopefully now you know a little bit about what the reuse is. So basically, end of life, a landfill is not the option, at least sustainable. We need to think more. Reuse, preferably reuse before recycling. And reuse is a reinstallation of recommissioned PV modules in other locations after appropriate quality control. I think I cannot, like, I should stress more on this quality control. This is absolutely necessary to be successful. And then the current state, there is a huge irregulated market, but that needs to be changed. And then there is a research gap on this testing protocol certification for convincing people or basically gaining the trust of the consumer. And also there are some small business operation around this case. Okay, with this, I'd like to thank you and thank you for your attention. And also I'd like to thank our collaborator PV Lab, CPVA, and in particular, Michelle is here, Gabe is here from PV Lab, Laura Jones from CPVA, she's not here, and Marco from ANU.
Thank you very much, Kevin. It was a it's a great talk. Yeah, I'm sure that everyone enjoyed it. So we have about 15-20 minutes for questions, and I just abuse my position and ask first question. So first you said you asked about how to define the end of life, right? I think it's a clear question. All economists have a clear answer to this question is when cost is higher than benefits, obviously, right? So, and for that, we need to be able to forecast based on testing, to forecast energy production, right? And then properly allocated cost will create business model. Otherwise, with all this incentive, it's not always work. You know, we know that. We need to encourage government to implement real cost models, so everything will go through. It's not easy, but that's interesting work for economists at ANU as well, right? To develop such a model. Especially, we need to understand the benefits of electricity that this module can produce in the remaining life, during the remaining life. But I have a parallel question to that, just a comment.
Okay.
Whereas then you said that maybe we will use this module in public housing or anywhere, right? So I think it's, I personally, I not 100% agree. Because, you know, the final product of any module, new or old, are electrons, right? They're all the same. We're not producing slightly low quality electrons as old modules. We're producing the same. So that means it's, again, public housing, not public housing, very expensive construction project, top level, plus a construction in Sydney of Darling Harbour. It is the same question. How much will cost production per electron, right? And if reusable module. So I don't think in this particular system, public housing for low-income people have specific niche, because you're not supplying less flashy kitchen or less, you know, polished tables, right? You're just supplying the same. That's mine. So any other questions, comments? Please.
Hello, Dr. Basnet. Thank you for your presentation. My name is Dr. Hugh Miller. I'm at Seven. I was fascinated by what you described about reuse of PV panels. But of course, when it gets to the true end of its life and reuse is no longer feasible, you briefly touched upon recycling. Can you tell us a bit more about how much can be recycled and the feasibility and profitability of that process?
And if I could just interrupt for a second, Dr. Rabin, if you could repeat or restate the question for the online audience, they'll hear you specifically.
Oh, okay. So, so you're saying that what's the profitability of the recycling as well as the current status of the recycling, right?
Yeah, and what's involved in that process?
Yeah, I think that's a really great question, and that is what everyone is trying to say. So yes, at the moment, recycling is the recycling concept is the main focus of end of life. It's because it doesn't classify. We don't need to classify as in a reuse. Basically, you don't need to do the intermediate test. You can just use everything for the recycling. And the recycling is very vague in the PV's area because, as I mentioned before, if you just can extract the aluminum frame, they can classify as a recycler. But in a true essence, that's not a proper recycling, right? So you need to extract the glass, the polymer, the silver, the copper out of it. There are, in terms of the R&Ds, already many methods like the chemical methods, mechanical methods, and the combination of other like a thermal methods has been demonstrated, and it seems like it's working. But in the commercial aspect, not many business has shown their profitability in the longer run at this stage. And that can be because that is not only because of the technology itself, and it's because of the incoming raw material for you. Basically, you don't have enough volume so that you can be profitable in your whole operation of the plant. But in the technology itself, currently there are lots of patents. So there is no sharing of the technology. That's what I feel. So people have several groups or several business are developing up this technology, but they are quite secretive. They are not sharing with the other because they think it as a basically a gold mine for them in a year. If they can survive for next few years, they know that the decommission volume will increase exponentially in the next 5 years or 10 years. And by that time, if they are being ready with the optimization of the technology, then they can be huge profitable. That's why, and basically summing up, at the current stage, the profitability is questionable. There is one company in the US called Solar Cycle that I think is doing a real good job. They are in a massive scale, and they are integrating not only the proper recycling, they are doing the other sector as well. They're opening the glass recycling company, and they're doing the reusing as well. And they basically work out their reverse logistic, the way they collect their PV panels, right? So from the different area. So if you have this integrated PV recycling concept, I think that has more chances of succeeding than just having a technology and you opening somewhere in a remote place and then expecting PV modules will come to your door, I think.
Thanks, Rabin. It was a great and interesting topic that you discussed today. Shared with us. My name is Dr. Milad Zaid, a researcher from AAU School of Engineering, has been working on the specifically more increasing performance of the solar panel PV module a couple of years ago. My question in terms of the reusing, so you're also considering repair as part of the reusing process, because you also shared some experiment work of your repairing of some old modules. So is it like categorized as a different area as a repair, or you also consider as part of the reuse cycle, and also you consider any costs associated with the repairing of those old modules that is going to be used in another location? So the question again, just quickly, is that repairing is part of reuse, or is it a completely different scenario there? And also, when you say reusing, is it the same location, or it has to be go to other location to be used, third country?
Yeah. So I think the repair, even though it's separated in that 10R strategy on its own, but for the reuse like aspect, I think repair can be a subcategory of reuse. So the reuse can be done either by repairing or without repairing. Both can be classified. Both modules can be reused. So basically, we're looking at the end results if we do reuse or not. So that's what we're trying to do. So in terms of the reuse on the same location or the I think what I understand is if you do the repair on the same location, that can classify as a extension of your lifetime, but not sure if that can be truly a reuse aspect, because you are not intending to decommission the panel on the first instance. So.
Arguably, it's the best reuse. Arguably, it's the best possible reuse.
Yes.
Maybe like a quick comment there that if you're going to consider reusing as like a niche market, there maybe having a small repair kind of strategy would increase their performance, and also the lifetime would also add more value on the cost and make people more motivated to reuse them by having the repair as small, like even just maybe adding a coating on the back sheet high. It
Yeah.
might be very cheap, but it would have paid.
Yeah, that's true. I agree with that. Yes, that's what we're trying to look at. Yes, yeah.
Okay, just sorry, we have one online question we need to give you. So can reuse panel compete for efficiency with 10-year newer panels, noting the rapid pace that solar PV technology develops?
Yeah, I think in a very simple term, maybe not, because if you look at, doesn't need to be repaired. So if you look at the modules from today and 10 years from now, there is a continuous improvement in the efficiency. So in terms of the efficiency, I don't think that they can compete. Yeah, that's what we're trying to say. So we shouldn't look at only from one aspect, only from either technology, okay, they are inferior, so they shouldn't be used, or only from the economic, okay, they are expensive to repair, so we shouldn't do it. So that should be a holistic approach on this one.
Techno-economic task, yeah. Please.
Oh, yes. Hi, I'm Adnan, from School of Engineering. I'm doing my master's in electronics engineering. I had a question on the repair aspects of the panels. Since you won't know the actual performance of the panel before the repair, how can you justify repairing a panel if it's going to perform much worse than what you expected?
Yeah.
Ideally, we should before and after. So if that's how you like basically that's how you sort out the modules either for reuse or a recycle. So in ideal case, you have one mobile system in your plant, and then you test everything, and then you classify them either this is for repair, this is for recycle, right? So that's where it starts, and then you do the repairing and then see if there is improvement. And then, yeah, then that's how you do it.
Yeah, and if I can add, with experience, you would understand more degradation modes. And by sign, we will understand, right? This will lead to a certain degradation. Any other questions? I have another question. If you don't have. So you mentioned repairing with silicone, right? Silicone, right? But probably it's not a good approach because silicone is knowingly moisture permeable material, right? Moisture can go to, I know that from my experience with trying to seal that solar cells. So probably the best way is to use products that use in food industry when we would prevent movement of moisture, and that's usually have a metal backing. We need to have aluminum backing. And many adhesive tapes, right? Plastic with aluminum on back of it, right? And you just adhere that moisture will not get in.
Yeah, I agree. There are a few studies on that adhesive test as well, but this, I think I mentioned silicone in my presentation, but this chemical was especially designed for this application. So Dow, they found, I think the backstory of this one is, so in the last few years, like almost 10 to 15 gigawatt of the PV modules, especially in Europe, they fell because of the backseat problem.
Yeah.
And
Dow was specifically designed silicone for this application.
Yes, so Dow, they developed this.
We should trust Dow then, right? We cannot question that. Right, any other questions? Yeah, please.
I'm just a woman in the street. With whiteboards, for example, I feel the companies pressure the consumer to turn them over as often as possible. Are you expecting a certain amount of pressure to come from producers of PV cells?
I think that's very, thank you, Maggie. Yes, it's happening. I think I heard several stories saying that especially the installer, they are trying to push the consumer to replace their existing system because they claim that the new system is better, cheaper. So that's where the installer is playing a role. And that's what we're trying to aim here. Hopefully in the near future, we'll go to the installer as well, try to convince, okay, try not to do that one, which maybe not.
Also, the government has mandates that you have your panels inspected.
Yeah.
And they find quite a few things that could worry a consumer. And they, I'll get a new one. So maybe they have to find some questions.
Yeah, that's true. Yeah, I think in that case, we need to be very careful. Yes, sometimes there might be fault, and that can be risky. Yes. But I think the classification of that danger or fault needs to be reclassified, maybe re-understood. Hopefully, this kind of conversation will start soon. because at least in Australia, there are few so this kind of outreach program along with the different stakeholder, government people, and policymakers. So we trying to talk to them and convince them, okay, this is the case. It's not only the use and throw. So we need to think of extending the life. And so we need to think from the top, like from the government aspect, right? They need to think reuse is possibility. I think at the moment they say blanket, no, that it cannot be reused from the policy aspect. So the policy needs to be rewritten, I think. Hopefully that's it.
But especially in high cost countries like Australia, because a major component of the cost is labor.
Yeah.
And labor is very expensive and there's a big portion of installation cost, right? So replacing, making a panel slightly cheaper will not change much because labor is a major factor in Australia. Right, thank you. So I have a very last question, and if we don't have any more questions, from what we have any questions? No. When you mention NeoIn panels, right? NeoIn.
Okay.
Yes, they have installation, and I understand they just lost the customer, mining company.
Oh yes, yes.
Right? But it's quite strange because they have a manufacturer of energy, production of energy. So, for example, it would be a good opportunity to use this electricity, I don't know, to produce hydrogen or to do something else with electricity to produce other products. So, is there any business models they're not considering at all?
Not sure. So I can't talk from their aspect. So maybe the location, yeah, I think that needs to think. I think that have to be planned quite ahead of time because they're already in the time of decommissioning, so they cannot plan the hydrogen right now. Right, hydrogen plant takes for commissioning of the plant takes another few years. I don't know how it
Maybe
takes.
some hydrogen company should buy it.
Yes.
Right? And we should make out.
Yeah, I think that should be done in.
All right. Okay, thank you very much.
Yeah, thank you.
It was a great presentation. Yeah, definitely join me.
Thank you.
So for everyone, thank you for attending our seminar and watch for our announcements. We'll have more energy related seminars coming soon.